The rapid development of technology results in both positive and negative effects to the environment. Creating a product can have profound environmental impacts that may not be initially obvious. Additionally, there can also be environmental impacts at every stage of development. The evaluation of the total environmental impact of a product at all stages of production is known as a life cycle assessment, or an LCA. Life cycle assessments were initially developed in the 1970s and were limited to the analysis of resource requirements and generated waste. In the 1990s, LCAs were given international standardization. At this time, assessment methods and processes were developed as well. Today, LCAs are extensively used throughout the world and have been substantially updated to encompass most aspects of product development, although there is need for improvement. To the right, there's a timeline that encompasses the development of life cycle assessments from the 1960s to the 2010s. As you can see, there's been substantial growth and development, however, there is still need for improvement.
A life cycle assessment is a comprehensive tool for systemic evaluation of the environmental impact of a product throughout each stage of its life cycle, from the extraction of raw materials to its disposal or recycling. It is also called a life cycle analysis, eco-balance, or cradle-to-grave analysis. The assessment takes into account all stages of the product's life cycle, including production, transportation, use, and end of life. It analyzes the environmental impacts associated with each stage, such as energy consumption, greenhouse gas emissions, water usage, and waste generation. It considers both qualitative and quantitative aspects. The goal of a life cycle assessment is to identify the areas in the life cycle where environmental impacts are the greatest, and to help reduce those impacts by identifying opportunities for improvement. It can also be used to compare different products or services to determine which has a lower environmental impact. But why do we need a life cycle assessment? The life cycle assessment is a way to study the impact of our goods, services, and technology on our environment. It helps identify the environmental consequence of a decision or a proposed change in the system under study. A life cycle assessment can help identify how we can implement ways of improving environmental footprint so our decisions today will be viewed as the right decisions in the future. It provides the framework for incorporating environmental effects into the decision-making process. A life cycle assessment is a valuable tool for businesses, policymakers, and consumers to make informed decisions about the environmental impacts of products and services and to identify opportunities for sustainable practices. A life cycle assessment follows a standardized methodology, which includes 4 main stages: goal definition and scope, inventory analysis, impact assessment, and interpretation and improvement analysis. The goal and scope definition stage establishes the purpose and scope of the assessment. The inventory analysis stage collects data on the products or services inputs and outputs through its life cycle. The impact assessment stage evaluates the environmental impacts associated with the inputs and outputs. And the interpretation stage evaluates the results and identifies areas for improvement. A life cycle assessment has a good scope and can be applied to any product or service, including food, buildings, electronics, and transportation. It can also be used to evaluate the environmental impacts of entire systems or processes, such as energy production or waste management. Some pros. A life cycle assessment provides a comprehensive view of the environmental impacts of a product or service, including both direct and indirect impacts. It also helps identify opportunities for improvement and innovation to reduce environmental impacts, increase efficiency, and lower costs. Additionally, a life cycle assessment can be used to inform policy decisions related to sustainability. Some cons. A life cycle assessment can be complex and time-consuming, requiring a significant amount of data collection and analysis. It also requires expertise in various fields, such as environmental science, engineering, and economics. Additionally, a life cycle assessment only evaluates environmental impacts and does not take into account social or economic factors. Overall, a life cycle assessment is a valuable tool for businesses, policymakers, and consumers to assess and reduce the environmental impacts of products and services and to promote sustainable practices. It's a versatile and powerful tool that can be used to assess and improve the environmental performance of products and services. It relies on comprehensive data collection and analysis and has several standards and guidelines to ensure consistency and accuracy in its application.
The first step to this process is to define the goals and scope of the assessment. This means that we must define what exactly is being assessed. Is it a product, a service, or something else? We must define what it is we are looking at. We must also decide how we will be assessing it. Using what systems of evaluation define how we will go about doing an assessment. The goals we have will change what areas of focus we have for this. We use different impact categories to help define this, categories such as climate change, acidification of soils and water, eutrophication of fresh water, marine and/or terrestrial ecosystems, depletion of different resource categories, and toxicity, among others. It is also important to decide what is outside the scope of the evaluation. Projects can have a really wide range of topics and implications that can make it difficult to tackle everything. Picking and choosing what is included and what is outside the scope allows for a more definitive assessment. Once we define the parameters of our assessment, we can begin the analysis of data. Phase 1 is to define what areas we gather data in, and so Phase 2 is the filling in of information in those areas. It is important to measure everything that is within the scope of Phase 1. All data is important for the following phases. Examples of data bank types could be raw materials or resources, different energy consumption, water use, and emissions. This data is generally collected by professionals who understand the standards expected from life cycle assessments. Oftentimes, there is a lot of data to be collected for an assessment. To ensure that no information is missed and to help with interpretation into the next phase, different methods to keep this gathered data can be used. One example of an information-keeping method is a flow model. This categorizes the information into groups that better show possible connections. This ensures that no information gets confused or lost somewhere. Nesting information within different groups can give a better view of the potential impacts of different elements.
Phase 3. Impact Assessment. In this phase, we take the data from the previous phase, life cycle inventory, and determine the significance of their impacts. This phase can be broken down into 3 steps. First, we have selection of indicators and models, then classification, and finally impact measurement. Selection of indicators and models. Recall that in phase 1 of the life cycle assessment, goal and scope, we have defined impact categories based on the goals that we have chosen. An impact category that could have been selected in phase 1 is climate change. But in this phase, we are now defining these impact categories more precisely. For example, we can choose to measure the impact of a specific greenhouse gas, like methane, on climate change. Next off, we have the step of classification. Here, all the inputs and outputs of the material are mapped to its relevant impact category. For instance, the inputs and outputs that produce greenhouse gases, such as carbon dioxide and water vapor, are allocated to the climate change impact category. Thirdly, we have the step of impact measurement. Here, impact category totals are summed up. If we look at the table and find the impact category of ozone depletion, we see a weighting factor of 30 euros. These weighting factors are determined by their relative impact on the environment. And since there are many human health risks associated with ozone depletion, due to the increased exposure to ultraviolet radiation, it makes sense why its weighting factor is relatively high compared to the others found in the table. Next off, we have our final phase, called interpretation. After accumulating all the data from the previous phases, we now verify any conclusions we've had and make recommendations as needed be. Here, we implement the International Organization for Standardization, ISO standard 14044, to conduct a check if our conclusions are properly justified. ISO 14044 is a set of guidelines for the life cycle assessment. This includes reviewing the prior 3 phases of goal and scope, life cycle inventory, and impact assessment. In addition, limitations of the life cycle assessment are identified, as well as the relationships between its 4 phases. By analyzing our data, we further ensure that it was all measured correctly and holds considerable accuracy.
Life cycle assessment, or LCA, is a widely accepted methodology for assessing the environmental impact of products and services. The practice of LCA is a mix of the ISO standards and a set of guidebooks that interpret, add, refine, or modify these standards. Some of the guidebooks that are commonly used in addition to the ISO standards are the ILCD Handbook, the Dutch Handbook on LCA, and guidelines from EPA, among others. However, these guidebooks are not necessarily formal standards and do not have the same level of authority as the ISO standards. They are more like guidance documents that provide recommendations and best practices for conducting LCAs. However, despite the widespread use of the ISO standards and these guidebooks, there are still differences between these standards and the real-world practice of LCA. For instance, there are differences in the terminology that is used, there's differences in certain methods that are conducted, as well as differences in certain quality control processes. For example, intermediate products that are produced during the manufacturing of a product that is being assessed are rarely mentioned in the ISO standards. However, they are commonly used within the real world. Additionally, the substitution method is frequently used in LCA, which is not always mentioned by the ISO standards. The substitution method is a way to compare the environmental impacts of two similar products by replacing one with a less environmentally damaging alternative and comparing the impacts of the two products. Another important aspect of LCA practice are the pre-existing additional standards that are dictated by the use of software and databases. Many software packages for LCA have built-in options for impact assessment and uncertainty analysis. At first glance, this may sound helpful, but they are often in a restricted form, allowing some options and restricting others. LCA databases are often constructed with predefined allocation methods and cutoff rules, so the user can't really choose otherwise. This significantly impacts the LCA process as a whole because some specific details about certain products aren't even allowed to be included within the LCA study due to the software and databases. Incorporating new insights into modern-day LCA practice is also a crucial aspect. The ISO standards come from about 1997 to 2000, and the 2006 update isn't really an update, it's just emerging, which means that the most up-to-date version of the ISO standards don't really reflect most practices that are being conducted today. Since 2006, there have been numerous developments that have been taken place that should be considered when conducting LCAs. Some of these developments include the distinction between attributional and consequential LCA. Attributional LCA looks at the environmental impact of a product or service based on the processes and resources used to create it, and it doesn't take into account any changes that might occur as a result of its production or use. Consequential LCA, on the other hand, considers the potential impacts of a product or service beyond just its creation. It takes into account the potential changes in markets, consumer behavior, and resource use that could result from the creation or use of that product or service.
Now that the life cycle assessment has been introduced and described by my peers, I will talk about who can benefit from its use. In general, there are many people who can benefit from the use of the life cycle assessment, but there are three main groups that I would like to focus on. Those being large corporations and companies, engineers, and the general population. There are four main benefits to using the life cycle assessment for big companies, as listed on the slides below. With the use of the life cycle assessment, companies are forced to comply with environmental regulations and can research new products in accordance to said regulations. Supply chains would be forced to be more environmentally efficient, as currently it accounts for 80% of the environmental impact when it comes to products and their production. Companies can market their environmental impact or lack thereof to potential consumers and create more executive strategies that be put into place to allow all of this to occur. Engineers can also greatly benefit from the use of the life cycle assessment. Through the evaluation of environmental impact, greener materials can be used and they can be used more efficiently throughout all stages of the design life, such as the increasing use of timber in mid-rise and high-rise buildings. We can also explore sustainability issues in different phases of construction and product life, such as the high use of concrete and the environmental impact of concrete, and we can also potentially use more greener materials such as recycled materials in concrete. Finally, us, the general population. Although the life cycle assessment is more used for people in higher levels and higher positions, we can still use it to our advantage. We can gain information for sustainable development, which we can then use to make sure that the people above us, the people in power, can keep their words and follow environmental guidelines, as mentioned earlier in the presentation. We can also use our knowledge to inspire change in our communities and allow others to do the same.